Hello there and welcome to this demo of Arctos Labs Edge Cloud Optimization technology. The demo uses 3 applications, all based on video, and one of them, the drone inspection, virtual inspections application, requires a low latency service, as it's using remote control to control the drone. The demo is based on 3 K3 clusters that are, 2 of them are representing on-prem locations and one is representing a public cloud. Cost models of the demo is favoring the on-prem locations and using the public cloud only when it's required. We have costs also for data transport between the on-prem clusters and from the on-prem clusters to the public cloud. The demo architecture is built upon 3 layers of functionality, one being the demo visualization, and then we have the cloud placement optimization and a multi-cluster orchestration capability. The visualization and the multi-cluster capability is built specifically for this demo, so to showcase the capabilities of the Edge Cloud placement optimization, and these control the 3 clusters. The dashboard consists of, on one hand, the demo control that you see here, where we launch new applications from various places, as well as you can see the application inventory. In the middle, you see the output from the placement optimization before deciding on deploying that, as well as you can see the actual deployment and the cost with the present applications. On the right hand side you see the K3 dashboards, where the top one is representing the public cloud, and the 2 windows at the right hand side is one of the on-prem clusters, and the other 2 is the other 2 on-prem clusters. The demo has, from the start, 3 applications already deployed. The demo starts by launching a virtual fencing application from Zone C, and you can see here that the recommendation, the advice from the placement engine, is to place that additional service, the green one here, not at the closest on-prem location, but at the second closest, the other one, because there was free available capacity there. The next step will be then to activate that placement advice, and you would now see the dashboards activating that. The second step would be to have a drone inspection service requested, and here you would see this one requires then low latency, so the advice would be to move the previously deployed application up to the public cloud to make room for the virtual inspection service there, because it requires a low latency, so it has to be on-prem. And then the demo moves onwards by activating that, and again you can see in the dashboards this moving on, the dashboard is being deployed, and we now have a new baseline according to the advice, and you see in the inventory all these 5 applications being deployed. The next step in the demo is that we're going to change the latency So you can now see the latency is now between these is now 12, and then this imposes a problem for the virtual inspection application, as that required a 10 millisecond latency. So now we're asking the placement engine for an advice, and you can see here now the advice is to move the drone inspection application to this location and swap this application to make room and to ensure that we have the right latency. So we're going to activate that placement, and now we have moved and migrated the drone application to an appropriate place. Next step is we're going to terminate the drone application because the mission is now completed. This means that we're terminating the application, and we now have room in this first location over here. And now when we're again invoking the placement advice with the re-evaluation, it concludes that we should move back home the service, the application that we had in the public cloud, and then we're basically activating that advice. And this concludes the demo.